Hello everyone and welcome to another AP Computer Science video. In this video we're going to finish up some more array ideas, but with one new twist to it. We're going to talk about a different type of loop which is often helpful for iterating over arrays in a particular set of problems. And really this is one of these things where it's an extra that you can choose to use or not. So just like with while loops and for loops, you can pick the style you want, and in reality they can both be written to solve the same problems. Some problems lend themselves to for loops more easily, some problems lend themselves to while loops more easily. This third version we're going to see really is kind of in between in the sense of what it does, and really we don't ever have to use it, but it sometimes some people believe that it makes programming certain situations much easier. And so we'll take a look at that as we do another array problem. Arrays, again, are the typical category of problems that this loop will help us with because it is multiple items. There's a lot of iteration, so this can be helpful. So we're going to go ahead and create a new class in our array stuff package. And we'll call it for each loops. For each loops. So the proper term in Java are called enhanced for loops. So they're basically like a fancy version of a for loop. They have the same intent. The aim is to go some number of iterations. They're also called for each, and so some languages use the actual keywords for each. Some languages like Java use just the word for, and they just change the structure of the content of the parameters or the parentheses section of the loop. So we'll see that now in a moment. So either one, for loops, enhanced for loops, for each loops, they're basically the same thing. Or they're just synonyms for each other in terms of their content. So let's go ahead and make a main. And so what we'll say is the primary difference between a for loop and an enhanced for loop is for loops do allow you to declare variables, and typically you make that counter, or that the term we would use as sentinel value. And it is often used as an index, for example, into an array or into a string, let's say, if we're using substring methods. A for each loop tries to do the same thing, but without the sentinel value. It says, you know what, the typical approach of create a sentinel value, use it to access some sub-value in an array or in a string or in a collection of things, and then put it in a temporary variable and then use it. Instead of doing all that work, it'll do it for us automatically. So we're going to do an example, very simple one. We'll start small and then we'll do a bigger problem. If I have an array of numbers, so let's go ahead and make an array of integers. Right, again, remember when we make arrays, we put our bracket notation, and that tells us it's multiple items. We'll call it numbers again, and we'll make a literal value. So we'll just go ahead and put some random numbers. And there it is. And we might typically loop through all the values in an array in this way. We would use a for loop. We would say int I is equal to 0. I is less than numbers dot length. I plus plus. And then we'd say, and I'm going to do this a little bit longer. We don't necessarily do it exactly this way, but I want to do it so that we can see an equivalent. And so we usually refer to the array value. We would say numbers at I. So we might say something like print out numbers at I, right? Numbers with the B. There it is, right? So if I ran this, again, we would see each number on a separate line, and that's fine. And that's, again, a solution, and that works. Now, again, it relies on the fact that we're accessing a particular value. Now, some people might say, well, to make it easier to read, we would do something like this. We might say int current number. And then we might move it over and put something like that. We might say, okay, we put the variable, we put it in a variable, and then we refer to the variable. Again, often many people are comfortable with the fact that you can just use the access directly because it is the value, but some people prefer to put it in a variable and then they can refer to the variable instead. And this is fine. But the point is that we have access to individual items. Now I'm going to do the same thing with the while loop, which we don't use too often now. Really, while loops are great for when the condition is not looping through a specific range of values. So we don't really need a sentinel necessarily to make that happen. Even though in this example, the for loop is better because we do need a sentinel. We do need to know which index to refer to in our array. But let's go ahead and try it with the while loop anyway. So I'll make a variable called index. We'll start it at 0. we'll say while our index is less than numbers.length. You can see the parallels here. We would go ahead and create our temporary variable. We will say numbers at index, and then we would print it out. Oh, current number, we'll print out, so again, to use the variable. And then the last thing would be the index plus plus. And so now in this situation, again, if I run this, we should see the exact same set of numbers doubled up. So now we see 1 to 10 and then 1 to 10. And so again, we can see the parallels. There's our sentinel declaration. There's our sentinel declaration. There's our while loop condition. There's our while loop condition. There's our for loop condition, and there's our while loop condition. There's our for loop update event, and then there's our while loop update event. They are exactly the same. Again, there is no, you only can do it one way. You can pick either version, and it's a matter of style and choice. Many people say the for loop is better in this situation because the I is temporary. It does this, and we can use it as a reference. Here, we had to make something externally. And so now, the new loop, the for each loop, or the enhanced for loop, is basically a for loop with the blending of, and the real advantage is this thing here is done for us. There's no need to refer to I. If we are unconcerned and do not need access to the index or the sentinel, then an enhanced for loop is something that we can take advantage. So I'm going to write some notes. We'll say enhanced for loop. I'll also say for each loop. It automatically accesses a value, accesses each value in the given collection and places it in a temporary variable. And then that variable can be referred to in that iteration, and then when that iteration is over, we can move on to the next one. So basically, it's basically the numbers at I part is done for us because we don't need the I, right? And so let's go ahead and try writing this. And again, the format is a little bit different, but the keyword for is still going to be used. So we're going to say for, and I'll put the format above it. We'll say the format is a for keyword. The data type of the variable or the content in the array. So in this example, it would be int, because this is an array of integers. If it was an array of strings, it would be string. If it was an array of booleans, it would be boolean. Whatever the data type is, and then a variable name. And then now here's where, again, this is very rarely used, but in this case, we're going to use a colon, not a semicolon, but a colon. And then the name of the collection we are working with or looping through. So in this case, our collection, I say collection mainly because shortly we're going to see another way of collecting data that in multiple pieces of data in the same group. And so arrays are one type of collection. There are other types of collections we'll see, and there are actually many that we won't see. So I'm trying to be generic and say collection of items, not necessarily just an array. So I'm going to say collection. And then our close parentheses. And then we have our, and again, this is just a matter of being consistent, our body. And so there it is. So the key here is that notice there is no I declared, there is no sentinel value that's an index to be referred to in this. Instead, what's going to happen is the internal mechanism will find the correct position, assign the value to the variable, and then we can refer to the variable. So in our example of mimicking printing these content, we could say for int. And again, the name does not matter, but now we're not going to call it I. Typically, we give it a name that represents what we're looking at. In this case, we're looking at an individual number, so maybe we'll call it num. And then now, what is the collection we are iterating through? It is the numbers array. So there's our for loop. Notice there's no errors. It doesn't complain. There's no I. So I can say, simply, print out num. And now if I run this, we should see the same set of numbers run 3 times. So there it is, 1 to 10, 1 to 10 for the while loop, and then now 1 to 10 in that for each loop. Now, the way I would say we read this, or the way I personally say it out loud in English words, is for every integer called num in the collection numbers. And again, this iterates one item at a time, assigns it. Again, what I'm saying is these two loops are exactly equivalent, except that the enhanced for loop does not show us, it hides behind the scenes, the sentinel or index value. And that has to be up to you to decide whether that's appropriate or not. If you think you're going to need the index, then an enhanced for loop is not going to be the tool you're going to use. But if you just need to look at the content, then an enhanced loop is a possibility. So it's a good choice for a lot of situations, but there are a good number of situations where it's not going to be effective. And so what I want to do is I'll write down some limitations of an enhanced for loop. Right. So the first one is we do not see an index or sentinel value. If we think we need the index, if we want to display it, if we want to use it to do some addition or a manipulation, we will not be able to do so. In fact, this limitation is a bigger thing than it might seem from this one sentence, because if we can't use I or ci or any sentinel value, that implies that we cannot look ahead. So I can't say I plus 1. Many algorithms might require us to look at two values at a time, right? The ith value and the ith plus 1 value. Or look behind. Look at the ith value and the ith minus 1 value. If we need to do that, or look ahead 5 times, whatever the amount of look ahead or look behind is, if that is required, we cannot do so with an enhanced for loop. Right? So we cannot use the index or sentinel value. That is a pretty big deal if your algorithm requires any kind of looking ahead or looking behind. And many, many algorithms do, so we have to be careful that we're aware of that when we're using this type of loop. The second limitation always starts right? So it always starts at the first index, whatever that happens to be. And again, for arrays, it's always 0, and goes to the end. Unfortunately, this limitation says there's no skipping. So if we had to go through every even index, can't do it. The enhanced for loop will only let you go through every value in the array, and does not let you skip around. You can't skip by 2. You can't go by 4. You can't go by every odd number, anything like that. It must always be every value will be visited from beginning to end, and also in the direction from the first item to the last item. So if we wanted to go backwards for whatever reason, this is not a loop that we're going to use. And so you might see just with these two limitations, you say, why would I ever want to use this? And again, and that's perfectly reasonable, but I'll say that it is often very convenient to write something very quickly. If I want to just print everything, an enhanced for loop is great because the content is what matters. That's the main difference. A for loop, you can get content, but the index also maybe is important to you. In an enhanced for loop, the only thing that matters to you is the individual pieces of content, the actual values themselves, and you don't care where they are or what order you see them in. You want to see each one individually. So for example, the summation of a list of numbers, an array of numbers, an enhanced for loop would be a good choice because you don't use the index to do a summation. You only really care, only as much as you need to refer to the value. What we care about is the value being summed up. So an enhanced for loop would be very convenient. Average, same thing. Now, finding the minimum, also we could use an enhanced for loop. Now, the find method that we did that returned an index, that could not be done with an enhanced for loop because the goal was to return the index that we saw. Here we don't know which index. We might find a match, but what index would it be? And with all that said, we could technically make another variable outside of the loop and keep track of that value and bump it up by 1, but then that kind of defeats the purpose. If you're going to do that, you're basically using a while loop or a regular for loop. So it's really a matter of choice, and you can always kind of warp it to do whatever you need to do, but most people would say if you're going to use the enhanced for loop, it's only because you care about the content in some simple fashion. And so that's pretty much it for enhanced for loop. So I want to do one bigger example, and this is just to try things out. Let's make an enhanced for loop that, given an array of strings, let's say names or sentences, goes through each one and prints them backwards. So if I go through the name Joe, J-O-E, then I'm going to display E-O-J, right? If I go through the name Bob, B-O-B, then I'm going to display the value B-O-B because it's a palindrome and is reversed the same way as it is forward. And so I have a collection of strings. I want to go through each string and print each of them backwards. And so here's a situation where an enhanced for loop could be used because when it comes to looking through all the strings, I don't particularly care. I want to go from the first one to the last one. The order is not important, not really. Now the accessing of individual characters, that maybe cannot be done with an enhanced for loop. So we'll see how we can do that. So let's combine this into kind of a big picture thing. Let's make a method that accepts a string, an array of strings, and generates a new array of strings of the backwards versions of all the words. I think that's a good choice. So I'll write the signature, and then I'll let you pause the video and attempt to implement it. And I'll give a brief description so you can try implementing it. So we'll say public because we want someone to use our method. Static because, again, our context is simply just the main, and we're not going to be using an object anywhere. Our return type will be an array of strings. I want to generate the array of the reversed values that were given to us. Our name, we'll call it genRev for generate reverses. And then our input is an array of strings. And we'll call it words. Right? So there's our signature. And again, I'll go ahead and briefly write a thing, and I'll give an example of what we might see. So we'll say, given an array of strings, generate a new array of strings where each value in the original is reversed and placed in the same location in the new array. The original should not be edited. So this is important. I'm mentioning that the original cannot be changed. If you reassign the original, you are not doing it the way I've asked you to. So I would say pause the video, give yourself a few minutes, implement this, and come back and let's see if you have a similar solution to mine. And again, there may be different versions. My goal will be to use an enhanced for loop. So you should try doing this with enhanced for loop where you need it. If you need more than one loop, that's fine. If you need nested loops, great. The idea is to try to use at least one enhanced for loop if it's possible, and see how that goes. So pause the video and give this a try. Okay, so hopefully you tried this and it worked out well. I know this maybe takes a little bit of thinking, but let's try to do this together and see how we do this. I'd say right off the bat, we recognize that we must return an array of strings, and it must be some size, so let's construct an array of strings. That's going to be our answer, right? It's not going to be a single string answer. It's going to be many strings put together into an array, so let's make that array. So let's go ahead and set this up. So to make a local array variable, we're going to do the same thing we always do. It's the type, which is string. It is an array, so we put our bracket notation. The name of the variable, I'm going to go ahead and call mine revs. And because this is happening when the program is running, we need to dynamically generate space for this array, so we're going to use the new keyword. It's very much like calling a constructor. We're going to be returning strings, so same data type string, and now here's where the size must be filled. How many strings do we need to reverse? The answer is the same number of strings that were in the original. How do we know how many were in the original array? Words.length. The length property tells us how many strings were there. So words.length. They're equivalent in size. If there were 5 strings in the input, there better be 5 strings in the output. So there it is. Now, my thinking is we've been given this group of words. Let's go through each of those words in the order that they show up, because we do need to keep them in the same places. So if the word Bob is in the first spot, then in the answer, Bob, the reverse of Bob, better be in the first spot. So we should do that. So here's where I think an enhanced for loop is convenient, because really when it comes to looking through the words array, all I care about is each individual word. Do I need to know what index they're in? No, I'm going from beginning to end. The order will not change, so an enhanced for loop works out nicely. I care about the content, the individual word. So here we go. For is our keyword. Our data type is string because it's an array of strings. The name of the variable, I'm going to call it W for word, or I'll call it WD for word. There's our colon. And again, the space between the colon and other things you don't need. That's just me writing. I like extra space. And then now our collection, what am I looping through? The original array input, which is words. So how would I read this? I would say for every word, or for every string in words, call WD temporarily. So there it is. For every string in words, WD. So let's try this out. Now I have the word, it's WD, so it might be, Jimbo, it might be Bob, it might be Joe, whatever it happens to be. Now we have to reverse it. So given a string, how do we reverse a string? Well, I think we're going to have to maybe generate a new string with the loop. So this is going to be a nested loop. Now we're going to go through each character in our string. Unfortunately, from the methods that we know and that the AP exam uses, there's not really a way to use an enhanced for loop to loop through a string. A string, even though it is technically a collection of characters, of chars, the enhanced for loop does not recognize it as such. It's a single object, so it's not going to work for us. So let's use a regular for loop, I think is a good choice. So for, and also accessing things in reverse maybe is helpful. So my plan will be to go backwards through the current string, WD, and add them to an answer in the forward direction. So we'll say string rev, or RV, is an empty string, or int I equal to, I'm going to start at the end of the string, so WD.length -1. I'm going to continue as long as the index is greater than or equal to 0. I'm going to go down by 1 each time. Again, here we're saying my choice is to go through every character in the current string backwards. You could technically start at the beginning of the string and then add them to the end of the answer in reverse order. That's okay too. But to make my summation or my concatenation simple, I'm going to go backwards. In fact, I don't really need this set of curly braces, but this is a one-liner. I'm going to say attach to RV the current character. And so the current character would be WD substring from I to I plus 1. Now again, it would be really nice to be able to use that bracket notation. Arrays make it seem so easy to access individual spots, but unfortunately, because this is not, even though internally it may be an array of characters, we must access content from a string through its method mechanism. So substring is how we get a single character. So if the word is Bob, this took the B, and then it loops again, and then it takes the O, and then it goes backwards and takes the B. If it was Joe, we start at the E, we add the E to the RV. We go to the O, we add the O, and then we add the J. So it's going backwards. At the end of this inner loop, we have the backward string, and now I want to assign it to the previous, or the same location in the original. Now here's where now we spot the flaw with this enhanced for loop. I need to assign it to a location in revs. Do I know what location it is? And the answer is unfortunately no, because the index is typically what tells us where it is. If I say revs equals RV, that doesn't work, because RV is a string, revs is an array of strings. So this is an array, so we have to use bracket notation. But now what's missing from this enhanced for loop is the index. So we have two choices. We get rid of the enhanced for loop and use a regular loop, and then we have an I or a J or whatever it happens to be. In fact, it can't be an I now because I've used I here. So it would have to be a J or something. And use that, or I can make an outside variable. And just for the sake of it, I'm going to make an extra variable. And again, it really does defeat the purpose of an enhanced for loop to do this, but I'm going to do it anyway just so we can see this in action. And we'll go ahead and say int, well, let's call it IDX for index. And we'll start at 0 because I want to start the first position of revs 0, 1, and so on. So I'm going to say revs at IDX is equal to the current string we just generated, and then of course we do have to do IDX plus plus. And again, this really does defeat the purpose of the enhanced for loop, which is kind of a sad result. But again, the problem is we need to always kind of plan out what we're going to do, and if we don't realize that an index is necessary, we may use the wrong structure. So really, you could avoid enhanced for loops all the time, and that's fine. And you can always have a for loop. And if you have no problem doing a little bit of extra work with bracket notation, then you don't have to ever use it. What I will say is for the AP exam, you will see enhanced for loops. They will use enhanced for loops in their code and their questions. So even if you choose not to use it in your code, you must be comfortable with reading and interpreting what's happening. So what's important here is we recognize that this iteration, this loop, will change WD to be each individual string in the original answers. So the last thing we need to do is after this outer loop ends, so we have this nested section of code, we can return the entire array, because it's an array of strings called revs. And so let's test this out and see if this does in fact work the way that I think hopefully that it should. So let's finish this up. Let's go to our main. This isn't our main, this is an example, so let's try this out. We'll say, let's make a test array of strings. We'll do a literal array. We'll say words is equal to hello, Jimbo, Bob, where. So there it is. And now let's call our method. Now remember, this method returns an array of strings, so let's make another variable to get the answer. If I don't put the answer, then I won't be able to display it. And so let's go ahead and say string array. We'll call it revs, or we'll call it reverse. And this is going to be the method call, genRev. The input is an array of strings. The only array of strings we have is words. So let's do words. And there it is. And then of course now we have the answer. Now here's a good place to use an enhanced for loop. I just want to simply print the content of reverse. We can say, for every string, str, or whatever we want to call it, in reverse. Simply print out on a separate line that string. So again, here the index was not at all necessary. I could have used a regular for loop or a while loop. But this is nice and short and compacted. So let's see what happens. Let's see if this works. And there it is. Hello backwards, Jimbo backwards, Bob backwards, and where backwards. Right? So this does in fact work. And so again, here I will admit that this was kind of like, well, we didn't really need to use it. We never really need to use it, but here it was not a great choice to use it because I really needed an index anyway. But here this worked out nicely. I didn't need an index. I could just print the content directly. But you need to be comfortable with reading enhanced for loops. If you choose not to use them, that is okay as well. So I'll stop the video here. We'll talk more about this. We will continue to use iteration and arrays, and everything we build on will definitely have kind of a, for the last couple sections, we'll have a reference to arrays in some fashion. So I'll see you in the next video.